Imagine this. A huge earthquake hits some remote mountainous place. Roads gone. Bridges out. And you've got hundreds of people stuck, needing help, supplies, maybe evacuation right now.
Yeah, tough scenario.
Or maybe a military unit needs to drop heavy gear deep behind enemy lines, way up high, no runway anywhere nearby. What machine can actually handle that?
There aren't many options for that kind of mission profile.
Welcome to the deep dive. Today we're really getting into the H-47 Chinook helicopter. People call it heavy lift dominance, and well, for good reason.
It's earned that reputation over decades.
Our mission here is to walk you through its really unique tandem rotor design, show you just how versatile it is across so many different missions. Look at the constant upgrades with the Block II program, and touch on its global reach and even its economic impact.
Yeah, it's got a fascinating story on all those fronts.
And just so you know, we've gathered a whole bunch of sources for this. Tech specs, operational histories, reports on its global use, milestones, all that stuff.
So we've got a good foundation to really explore what makes this aircraft tick.
Okay, let's dive in. When most people think helicopter, you picture that one big rotor on top and a little one on the tail, right?
Standard configuration, yeah.
That tail rotor's job is basically fighting the spin from the main rotor. But the Chinook, it looks totally different. Two huge rotors, front and back. What's the deal there? Why that setup?
That tandem rotor design is really the heart of it all. It's what gives the Chinook its edge. See, instead of needing a tail rotor to counteract torque,
Right.
you have these two large rotors spinning in opposite directions. They effectively cancel each other's torque out, naturally.
Ah, okay. So it's inherently stable then.
Exactly. It provides fantastic stability and control, inherently. And despite its size, it's surprisingly agile. Think of it like a very nimble truck, maybe.
Yep. No.
And this balance helps it handle tough wind conditions way better than most single rotor designs. Crosswinds, gusts in the mountains. It's much more capable. Plus, practically speaking, getting rid of the tail rotor means the whole back end is clear.
For the ramp.
Precisely.
Yeah.
Unobstructed rear ramp access. That's absolutely critical for quickly loading big cargo vehicles or a lot of troops.
So, okay, this is where it gets really interesting, especially if you think about what it can do. This design lets it operate in ways other helicopters just can't. Tell us more about that.
Yeah, absolutely. That clear rear ramp, like we said, no tail rotor back there. That's huge. It means the Chinook doesn't need some perfect flat landing zone. It can literally back up to a steep slope or a damaged building, even a ship's deck, and load or unload right off the ramp. In disaster zones or combat situations, that ability to use rough terrain is invaluable.
I can imagine.
And then there's the famous pinnacle landing. You have to see this to believe it sometimes.
What's that exactly?
The Chinook lands just its back wheels on a really small elevated spot, like a sharp mountain peak, a narrow ridge, maybe even a rooftop. The rest of the aircraft just hangs there in the air. The pilots use that incredible control from the tandem rotors to just perch the back end, keeping the front clear and the ramp usable.
That sounds incredibly difficult.
It takes skill, no doubt, but the aircraft's stability makes it possible. It opens up access to places almost nothing else can reach. Think special ops, high mountain rescue.
Yeah, vital stuff.
And add to that its performance at high altitude. The Chinook can fly up to 20,000 feet.
20,000. That's impressive for a helicopter.
It really is. Most helicopters lose a lot of performance in thin air, but the Chinook's powerful engines and that efficient rotor system let it keep lifting and maneuvering way up high. That makes it the go-to for mountains or hot climates where density altitude cripples other aircraft.
Okay, so the physical design is clearly revolutionary. But it's not just about the rotors and the airframe, right? This thing must be loaded with modern tech inside too.
Oh, absolutely. You can't stay relevant for this long without keeping the insides cutting edge. The technology is just as important.
So what are we talking about? What systems help it handle all these different missions?
Well, inside the cockpit, it features a fully integrated digital system. It's called the Common Avionics Architecture System, or CAAS cockpit. That's paired with a digital automatic flight control system, DAFCS.
Okay, sounds complex. What does that mean for the crew?
It means much better situational awareness. It basically pulls together data from all sorts of sensors, flight data, weather, terrain, even potential threats, and displays it clearly for the crew, like having a super smart co-pilot constantly analyzing everything.
Right, helps them fly in tough conditions.
Exactly. Zero visibility, busy airspace, complex tactical environments. It gives them a level of precision and safety that wasn't possible before. And beyond the cockpit, you have advanced cargo handling systems too. Winches, rollers, tie-downs, making heavy lifting efficient and flexible.
Gotcha. And it's not just what it lifts, but how far it can take it. How does it manage those really long-range missions?
That's another key part of its capability, getting that heavy lift capability deep into remote areas.
Yeah, refueling must be an issue sometimes.
It can be. Now, they can fit it with extra fuel tanks, simple extended range tanks for longer flights. But the real game changer, that's its air-to-air refueling capability.
It can refuel in midair, like a fighter jet.
Pretty much, yeah. It can hook up with a tanker aircraft during flight. This allows it to fly, as they say, farther than ever before.
Wow, that really changes things.
It transforms it. It's not just tactical anymore, it becomes strategic. It can deploy across oceans, stay on station for long special ops missions, or support disaster relief efforts for extended periods without landing for fuel.
How does that work physically for a helicopter?
It uses a hose and drogue system. The tanker trails a hose with a sort of funnel, the drogue, at the end. The Chinook pilot maneuvers a probe into that drogue to connect and refuel. It takes some serious flying skill, especially in a big helicopter.
I bet. So when you think about all these technologies, the digital cockpit, the refueling, what really strikes you about how they expand what the Chinook can do?
For me, it's that blend. You've got this brilliant foundational aerodynamic design from decades ago.
Right, the tandem rotors.
Combined with cutting-edge digital systems and these strategic range extenders, it's like taking a classic, powerful design and constantly infusing it with the latest smarts and endurance. It keeps it ahead of the curve.
It's amazing it stayed relevant for so long.
Yeah.
But that takes constant work, right? Which brings us to the Block II upgrade. Why is this modernization so important?
Yeah, you don't dominate for over 50 years by standing still. The Block II program is absolutely crucial. It's not just a refresh, it's about proactively meeting what the military calls the warfighter's ever-evolving needs.
Keeping it ahead of future threats and demands.
Exactly. Making sure it stays the most advanced and capable heavy-lift aircraft in its class. And they're doing that with some serious upgrades. Redesigned fuel tanks for better capacity and survivability. A stronger fuselage to handle even heavier loads and more operational stress, and an improved drivetrain for more power and efficiency.
So it can lift more, fly safer, operate harder.
That's the idea. It directly helps soldiers meet today's heavy lift needs, which are only getting more demanding with heavier equipment and faster operational tempos.
Looking at the bigger picture then, it sounds like Block II isn't just about today's problems. You mentioned long-term solution. What makes it future-proof?
That's really the strategic genius of Block II. These structural improvements, the strengthened fuselage, the new drivetrain, they aren't just for now, they create a more robust platform that allows for future upgrades later on.
So they're building in room for growth.
Precisely. It ensures the Chinook can adapt to challenges we haven't even thought of yet. It's about having that capacity built in. And they're investing in key technologies like open systems architecture for the avionics.
What does open systems mean here?
It basically means it's easier and cheaper to plug in new tech or upgrade components down the line. You're not locked into one specific vendor's proprietary system. It allows for faster, more affordable upgrades as technology evolves.
Makes sense. Keeps it adaptable.
And that adaptability contributes to achieving decisive overmatch. That's the goal, having superior capability across all domains, land, sea, air, space, cyber, to dominate potential conflicts.
And you mentioned joint all-domain operations.
Right. That's about coordinating forces seamlessly across all those different environments. The enhanced Chinook with Block II can move forces and supplies rapidly across these integrated battlefields, providing a crucial advantage. These upgrades ensure it's prepared to fight and win for decades to come.
It's clear it's vital for the U.S. military, but you mentioned it's a global asset too. How widespread is its use internationally?
Oh, it's huge globally. It's not just the U.S. Army, Reserve, and National Guard. You've got 20 other countries operating Chinooks.
20? Wow. Like who?
Major allies. We're talking
Yeah.
Canada, the UK, the Netherlands, Japan, Italy, Greece, Spain, South Korea, Australia, Turkey, the UAE. Germany just selected it too. The list goes on.
So there are a lot of them out there.
Over 950 Chinooks flying in those 20 international forces. It really speaks volumes about its reliability and versatility. You see countries like Italy and Spain celebrating 50 years of flying Chinooks recently.
Incredible longevity.
Absolutely. And others, like Egypt and Germany, are buying new CH-47s now. Plus, Block II upgrades are already being delivered to international partners like the Netherlands and for U.S. special operations. Its global footprint is massive and still growing.
Beyond the military side or disaster relief, there's also a big economic story here, right?
Yeah.
Especially for the U.S. industrial base.
Definitely. That's often overlooked, but really important. The Chinook program supports a huge number of jobs. We're talking more than 20,000 jobs and 360 suppliers across 40 states, just in the U.S.
It was a big employer.
Huge. And it's not just jobs, it maintains a critical industrial base, skills, and technologies within the country. That's vital for national security. The Block II production strengthens this base, ensuring we can build and support these crucial aircraft.
And that probably helps with costs, too.
It does. Having that established, efficient production line and supply chain contributes to what they call unrivaled production, maintenance, and sustainment cost efficiencies. It's a smart investment in that sense, too.
And what about keeping them flying? These are complex machines operating all over the world. How is the ongoing support managed?
That's a massive undertaking in itself. Boeing plays a huge role there, obviously. Their goal is to optimize readiness for the entire global fleet.
So maintenance, repairs, logistics.
All of that. They offer a whole range of services. Performance-based logistics, integrated fleet support, maintenance, modifications, repairs. Basically everything needed to keep the Chinooks mission ready.
Tailored for each user.
Exactly. Tailored to what each country or unit needs, aiming to reduce the total cost of ownership over the helicopter's life while maximizing its availability and performance. It's a full life cycle support system.
Okay, to really nail down just how capable this machine is, let's hit some numbers. What are some specs that really stand out and give you a sense of its scale?
The numbers are pretty staggering when you look at them. The rotor diameter, 18.29 meters. That's 60 feet across. Just imagine that.
That's huge, like a building wing almost.
Pretty much. And the total length, with rotors turning, is over 30 meters, nearly 99 feet long. Longer than 2 buses end to end.
And speed. Is it fast for its size?
Surprisingly fast. Maximum speed is around 302 kilometers per hour or 170 knots. It can actually outrun some smaller helicopters.
Ugh.
And that service ceiling we talked about, 6,096 meters, 20,000 feet. That capability to fly high is key.
Right. But the big one is lift, right? Heavy lift dominance. What are capacity numbers?
This is where it really earns its name. Max gross weight is 24,494 kilograms. That's 54,000 pounds.
54,000 pounds. What's that comparable to?
Think about maybe 15 or so fully loaded pickup trucks. Something like that. A massive amount of weight.
Wow. And the useful load, what it can actually carry?
Useful load is 12,565 kilograms or 27,700 pounds. That's the payload, troops, gear, vehicles, supplies. Enough to carry dozens of soldiers or a Humvee or critical relief supplies into anywhere, basically.
So, hearing those numbers, seeing the specs, what's the takeaway for someone trying to grasp the Chinook's impact?
I think it makes it tangible, right? These aren't just abstract numbers. They directly show you why it dominates heavy lift. They explain its versatility, that weight capacity, that altitude performance, that size combined with agility. It all comes back to the engineering specs that enable its unique multi-mission capability. It's why it's so indispensable.
Well, this has been a fantastic deep dive. We've really covered a lot of ground, that unique tandem rotor design, giving it stability, agility, those amazing pinnacle landings.
Yeah, the high altitude stuff too.
Right, and the strategic importance of Block II, not just for now, but for keeping it relevant for decades. Plus its huge global reach and the economic engine behind it.
It really is a remarkable story of design and evolution.
It makes you think, doesn't it?
Yeah.
Here's an aircraft design, fundamentally, that's been around and constantly delivered for over half a century.
Still pushing boundaries with Block II.
Exactly. So it raises this question. In a world where tech changes so fast, what is it about certain core designs, when they're constantly updated and adapted like the Chinook, that lets them stay so utterly essential for so long?
That's a great point. It speaks to getting the fundamentals incredibly right from the start, but also having the foresight to build in adaptability. Maybe something for you, the listener, to ponder what other technologies have that kind of enduring legacy and why is that continuous evolution so critical.